Okay. Now we're going to look at how would we solve if we didn't have a graph. We're going to solve systems. So we can solve systems of linear equations by graphing. Where two points, the point where two lines intersect is called the point of intersection. Which we can abbreviate to POI. The points x and y values are the same on both lines, or they're equal. So that x and y value works for both lines. However, graphing cannot always determine an exact solution or an exact POI, right? We could have decimals or fractions. Or it could be way off our graph. When we can't graph, we can use different algebraic methods to find an exact solution. So let's look at an example. I'm going to give you the steps. We're going to go over one, and then we'll go from there. First part, we're going to label the equations or the relations. I'm going to call one equation 1 equation 2. Next, we're going to choose one of them, and we're going to rearrange it to isolate one of the variables. Now that's already done for us. We already have y by itself in the first equation. We already have y by itself in the second equation. So really, that's already done. The next thing we're going to do, the one that we rearranged, we're going to substitute it. So substitute. So we're going to rearrange the substitute equation, and we're going to take the rearranged equation and substitute it in. So to keep that and to show me what I'm doing, I'm actually going to communicate, proper math communication. I'm going to say sub equation 1 into equation 2. Good communication. So here's equation 2, y equals 3x plus 5. And everywhere I see the y in equation 1, I'm going to put what y is worth. Everywhere I see the y in equation 2, I'm going to put what y is worth in equation 1. So instead of y on the left side of equation 2, I'm going to have negative 2x minus 5. Now by substituting, there are no more y's left. There's only one unknown, one variable, x. So because of that, I can solve for the unknown variable. Now all my rules for algebra still apply. Plus 2x on the left, plus 2x on the right, take away 5 on the right, take away 5 on the left. So that's step B. Minus 5, take away 5 more is minus 10. 3x plus 2x is 5x. 5, take away 5 is 0. Continue to solve. Divide by 5, divide by 5. X equals negative 2. Remembering that, the whole point is I'm trying to find a point. So the x value of where those two lines cross is negative 2. Now I'm going to take that solution that I just found. I'm going to substitute it back. And I'm going to substitute that back into one of the original equations. So again, following my math communication, I'm going to sub x equals -2 into 1 or 2. I'm going to choose 1 because that's the one that I rearranged. And once I substitute it back in, I'm going to solve. So y equals -2 everywhere I see x. I'm going to put what x was worth. I solve. -2 times -2 is +4. 4 take away 5, -1. And then my last step, I'm going to state the point of the intersection. Therefore, the POI is -2, -1. That's just a point. Okay, let's see if we can do it again. Follow the steps. So I labeled them. Even though this is question 2, that's equation 1, equation 2. Rearrange. Oh, this one already has rearranged for x. So now I'm going to, this time, sub equation 2 into equation 1. So in equation 1, everywhere I see x, I'm going to put what x is worth. Now I'm going to solve. Y plus y is 4y. That's -3. I'm going to add 3 to the left, add 3 to the right. That equals 12. Divide by 4, divide by 4. And y equals 3. So remembering that, I have now found what y is worth in that point of intersection. I take y equals 3, and I'm going to sub into either equation 1 or equation 2. It doesn't matter, but because x is isolated, I'm going to choose to sub it back into equation 2. X equals, everywhere I see y, I put in what I solve for y, and then I solve. My final step, my communication, therefore, the POI is 0, 3. If I was ever concerned or I want to double check, I could sub in x and y into my equations. When x is 0, y is 3. 0 plus 3 times 3, which is 9. 0 plus 9 equals 9. Yeah, that point is on the first line. What about the second one? 0 equals 3 minus 3. 3 minus 3 is 0. 0 equals 0. Yeah, that point is on the second line. That point's on both lines. They intersect there. Flip the page. Let's try another one. This one, again, we follow the same pattern. Equation 1, equation 2. We see that right now we're going to have to rearrange. I can choose to rearrange for x, might be easier in the first equation, or y in the second equation. If I choose to rearrange the first equation, take away 2y from the left, take away 2y from the right. I now have x equals 1 minus 2y. Again, I can choose the order. I'm going to substitute equation 1 into equation 2. Everywhere I see x in equation 2, I'm going to put 1 minus 2y. Now, all previous math still exists. To solve, I need to use the skills I have. I need to distribute. 2 times 1 is 2. 2 times -2y is -4y. collect like terms. Minus 2 on the left, minus 2 on the right. Negative 4y plus a y is negative 3y. 3 minus 2, negative 3 minus 2 is negative 5. Negative divided by negative is positive, and now I have my y value. I need to continue and sub y equals 5/3 into, again, equation 1, equation 2, or my rearranged, my new equation 1. I'm going to sub it back into equation 1, my rearranged, because I already have x isolated. All previous math still exists. 2 times 5 is 10, divided by 3. Adding, subtracting fractions, I need to find a common denominator. Remember that 1 is like 1 over 1. So I'm going to times by 3, times by 3. Now that I have a common denominator, 3 take away 10 is negative 7, all over my common denominator, 3. And now I have my point of intersection. Point of intersection is negative 7/3 and 5/3. Let's continue with example 4.